Hello, math students. Welcome back to Module 4, Expressions and Equations. This is Lesson 4, Replacing Letters and Numbers. The goal for today's lesson is, today we will learn what a variable is and how to use it to evaluate expressions. The question that I want you to be thinking about in this lesson is, can a single letter stand for for more than one numerical value? Explain. Things to know in this lesson are, a variable is a symbol, usually letters, that is a placeholder for a number. Okay, it temporarily holds the value of the number because we don't know what it is, so we use a variable until we figure it out. An expression is a math sentence that has one or all of the numbers replaced with variables. An example of an expression is 1/3 times the quantity x plus y plus z. Evaluate means to solve a given expression, equation, or problem. So an example of that would be x plus 3 equals 5. So you understand that 2 plus 3 equals 5, so x would equal 2. Area is the space that is located inside a given shape. To find area, you take the length and you multiply it by the width. Multiplying two things makes it two-dimensional and squared. Volume is the space inside a three-dimensional shape. To find volume, you must take the length and the width and the height and multiply them together. Multiplying three things together makes it three-dimensional, and so it's cubed. Okay? The next thing that I need you to know is additive identity property of 0, and this property means any number added to 0 will always result in the number itself. So if you take 7 plus 0, you still get an answer of 7. If you take 1/2 plus 0, you will get an answer of 1/2. If you take t plus 0, you will get an answer of t. So that is called the identity property of 0. The next property that I need you to know about is the multiplicative identity property of 1. And what this means is any number multiplied by 1 will always result in the number itself. So if you take 7 times 1, it equals 7. If you take 1/2 times 1, it equals 1/2. If you take t times 1, it will equal t. And then the last property that we're going to talk about in this lesson today is commutative property of addition and multiplication. The order that you add or multiply numbers does not matter in the commutative property. The solution will always be the same. So for example, if you have 2 plus 5, you know that 2 plus 5 equals 7. And then if you check it and you do 5 plus 2, well, 5 plus 2 equals 7. So that you know that you can see that order and how you add these two values together is still going to result in the same answer of 7. Okay? It also works with multiplication. So if you take 3 times 9, you know 3 times 9 equals 27. And then if you were to take 9 times 3, you know that 9 times 3 equals 27. So they are equivalent. So again, this proves that when you multiply, it doesn't matter the order of the two numbers that you're multiplying together, they will result in the same answer. Okay? You can do this with fractions as well. So if you have 1/2 plus 6/4, then you do have to remember that in order to add fractions, you have to have a common denominator. So we would just change that to fourths. And so you get from 2 to 4 times 2. What you do to one side, you have to do to the other. So this is 2/4 plus 6/4. And when you add those two together, you get 8/4, which is also equal to 2. So now let's do the other side and see if it works. Remember, you have to have a common denominator. So this is 2/4 plus 6/4. 6/4 plus 2/4 equals 8/4. And 8/4 is the same as 2. So you can see that even when you're doing it with fractions, you come up with the same answer, and so fraction adding is commutative as well. So as long as you are adding or multiplying, the commutative property works because it doesn't matter the order that you combine your numbers, they will result with the same answer. Again, looking at one more example, if you take 2 times t, you get 2t. And if you take t times 2, you would still get 2t, and so you see that your result is exactly the same. Okay? So In today's lesson, we did a whole bunch of vocabulary words, and let's go back to our goal. Today, we will learn what a variable is and see how to use it to evaluate expressions, and we did that with this example right here. If you have x plus 3 equals 5, and we can use a tape diagram of that, so we know that the total tape has 5 sections in it, so 1, 2, 3, 4, 5. And we know that 2 of them have a value of 3, or excuse me, 3 of them have a value of 3, and the whole thing right here is 5, and we know according to the equation that this is x, so then you just have to ask yourself, what number plus 3 gives you 5, and so you know x equals 2. And that's how we're going to be working with using variables to evaluate expressions. Okay? Talking about letters representing the unknown amount until we figure it out, and then remembering all these other vocabulary words that you're going to see when you do practice problems in class. All right, kiddos, that's all I have for you today. Let's go back really quickly to our question. Can a single letter stand for more than one numerical value? The answer is no. If there is another numerical value, then you have to choose a different variable, because one variable always stands for one numerical amount. And so since it only holds one numerical amount, that means that you have to choose another variable when you're talking about another numerical amount. Okay? All right, kiddos, that's all I have for you today. Talk to you soon. Bye.